Let's move on to Educator Assessment Worksheet. We have over here a list of high school educators. We know when they were hired, we know the years of service, the salary, and the township. And we would like to create a scatter chart in which to plot the years of service and the salary. And let's see if there is any connection and if we can create a trend line. So let's go ahead and create that chart. It's a chart, so we go to Insert. Now this chart is special, so I want to position my mouse somewhere where I want to locate it. And then I go to Insert, and from the Charts group, this is what I need. The Scatter chart is right there. And we can select the first option, Scatter. And then we need to select the data for it. So you can go select data or right click it. And we're going to add the series. You can give it a name, but we're not going to show the name. And for the X values, we want to take the years of service. So we start from the top, the first number, Control Shift down arrow to select them all. And then for the Y values, I'm going to remove what's here. And we're going to start from the top salary, Control Shift down to the bottom one. And let's push OK. When you look at the chart, you can actually see how having more years of service will automatically be associated with a bigger salary. But we can do more than that. So let's hit the plus sign and let's go to the trend line and to more options. And we're going to have a linear, you can see it right there. But we want to show also the equation on the chart and also the R squared value on the chart. Equation over here, what does it tell us? If you have, for example, 10 years of service, so then you're going to put instead of X 10. So it will be 2967.3 times 10 plus 16304. And that will give you the actual salary for 10, which would be somewhere here. Okay, and then the R squared is a percentage. So if it's closer to 1, then it's more accurately the trend line. Right now we have 0.8928, so that's pretty close to 1. The linear equation is this one, y equals, okay, so that's our equation. And you have the explanation over here. So y is the predicted salary and x is the years of service. So all you have to do is plug in the values. The value for x to get the value for y. Let's calculate now the intercept, and there is a function named just so intercept, and we have to put the known y's. So what do we have on the y-axis? We have the salaries. So let's go ahead and select them all, starting from the top, Control Shift down, comma to go to the next argument, and the x's would be 0. So all these are the years of service. Let's start with the first one, Control Shift down. And we can push enter, and the intercept, we got the same intercept right there. Okay, so that's the value in the linear equation right there. Let's see the slope. So the slope would be using just the same idea. For the y's, we're going to select the salaries, Control Shift down, and for the x's, we're going to get all the years of service starting from the top. Okay, and let's check the slope, and you can actually see it in the linear equation. Let's calculate now the R squared. So the name of the function is RSQ. Known y's would be again all the salaries. You can see them right there. Comma to go to the second argument, and no x's would be years of service. And let's push enter. And we got the same R squared as you see in the trend line, 0.89. So that means that the linear trend line accurately represents 89% of the data observations. Let's calculate now the standard error. So let's see what the name of the function might be. And if you scroll down here, returns the standard error of the predicted y value for each x in a regression. So we can use STEYX. Known y's, again, these are the salaries on the y-axis. So let's select them all, Control Shift down, comma to go to the next argument. The known x's, all these numbers for the x-axis would be the years of service. So let's select them all. And that's the standard error. So basically, if you get the Y representing the salary based on the years of service, which is X, that predicted value can go up or down by the standard error. Okay. So let's see an example. For 30 years of service, what would the predicted salary be? You can use the chart, but let's go ahead and actually use a function. And there is a function, forecast.LINEAR. That's exactly what we have. We have a linear forecast. And then X would be, you can get more help if you want, but X would be the years of service. Okay, so that's what we want to forecast for. And then the known Y's, again, on the Y we have the salary, so let's select them all, starting from the first one, and then a comma, and then let's go and select now the years of service for the known X's. Okay, let's push enter, let's see what we have. So the predicted salary should be 105,322. But now remember the standard error. So that salary might go up by the standard error. So we can say up by that, okay, from here. And also from here it can go down by the standard error. So it can fluctuate in between these two numbers. Okay, that's the prediction. Now let's check this manually with our linear equation. So I'm going to put here check, and let's try our formula. Okay, so we know that the Y here should be 2967.3. So what's that? That's the slope, right? So let's select it, times the X. Okay, so remember the X should be the years of service. Now plus, and then we have the intercept. So I'm going to click the intercept. And let's see what we got. Okay, and if you want to check even decimal places, you can do that. But it looks like we got our number. Okay, let's just see the decimal places here. Okay, and let's actually do the same F4 when you want to repeat the last command.